Yeah, thank you so much, Greg. I really am excited to present this today. It's been roughly, about 8 to 9 months of progress and work through this project as a pathway student at the WFO St. Louis office. So, really excited to share with you today about my tropical cyclone climatology that I've created using the ArcGIS online story maps, as well as a plethora of different other functions that GIS Online has allowed us to use to visualize our data. So with that, I'll get into just the climatology itself. So what basically I'm doing in this presentation will be giving a overview of the story map itself. So these will be mostly static images of the climatology, but the climatology itself will be made public hopefully in the next week or so for everybody to be able to see the full page on its own. So that being said, the main purpose of wanting to create this TC climatology was that we wanted to be able to have a page that was dedicated to providing information about tropical cyclone impacts to our area for our partners, the general public, as well as having some element of usefulness for the forecasters within the office so that they are more familiar with just the general impacts and types of events that can occur with these tropical cyclones. And so what we did was we were basically looking, with St. Louis being such a far inland area, it's not going to be as easy to fully identify every single case, especially given the fact that most TCs at this point are undergoing extratropical transition or dissipating. So we did provide a pretty large 300-mile wide radius away from the St. Louis area to capture more wide, broader impacts that these TCs provide when they move inland. And that allowed us to identify roughly, basically, we found 52 cases since 1851 that followed that criteria of TCs that were in the HERDAT2 or best track data that fell within that 300-mile radius. Looking at a broader view of how all these tracks look when you zoom out, we can see that a lot of them originate from a different, basically different areas of the Atlantic Basin. This is specifically for the Atlantic Basin, although you'll note that there is some crossovers that were identified. But we wanted to strictly stick to the Atlantic Basin, just given the fact that there's a little bit more complication with trying to find specific cases that cross from the Pacific Ocean over, and most of them are pretty extratropical and not really directly TC related at that point. But that being said, with the amount of storms that we identified, roughly about every 2 to 3 years, we see a TC impact in this area. And the distribution is primarily with September and August and June as our primary months of impacts, which is interesting with June, given the fact that that's not obviously peak climatology for TCs in the Atlantic Basin, but given the fact that formation is occurring much closer to land during that time, it makes more sense, I guess, in that regard, that June would be a little bit more active than climatology would suggest, broadly speaking. Getting into how we wanted to identify, some of the hot spots that these tracks follow. And we can see that the majority of the tracks basically come, whether they form in the Atlantic or they form further west, they all usually track through the Gulf of Mexico before they reach St. Louis, with the primary hotspots being definitely in the Houston and New Orleans area. However, I wanted to go ahead and acknowledge that there is a subtle cold spot that we kind of identified within these tracks that kind of show a bifurcation of the tracks between two different scenarios that we'll get into here in a second, and differences in tracks that could definitely have differences in impacts. And then I also wanted to talk about the TC dashboard that basically allows the user to have a more interactive, basically just it's a sandbox. You can play with the data and look at all the different data points, different storms, and basically just have fun, like looking at all the different TCs that are impacting our area and learn more about the history of TCs that impact St. Louis. The tabs down below are going to provide histograms of different, basically kind of the stuff that we had shown, but just a little bit more intimately with each, the count of each month, as well as for the decades. We wanted to identify the decades that were most active for the area, with the 2000s, 2010s, and 1900s being the most active that we identified. And then also the storm by category, which we noted that, which pretty commonly we see tropical storms in category 1s as the most common intensity for most TCs in the Atlantic Basin. But it was interesting also to see that there was quite a few category 4 storms, which makes sense given the fact that stronger storms are going to take a little longer to lose their strength as they move inland. That being said, I wanted to also bring your attention to this interesting feature that I was able to look into, which was the filter storm data options that we had, which allowed us to sort by month for the storm. So if you wanted a query of, okay, I'm looking for a specific storm that I think happened in, let's say, September. And so now we have sorted all of the storms that occurred in September. And let's say that, well, I wanted to also mention too, what's really cool is you can click on these storms and it'll give you the information based off of what we had sorted through with the data, so that people can basically click on whatever point that they would like and get more information on that storm wherever that may have been. But moving on to the other parts of the query, we have the sort by decade option as well. So if we wanted to take our September storms and look at the 2000s and what all the 2000 storms that happened in September, now we have a pretty refined search now of what storms that occurred during that period. And if you wanted to expand that search to say 1980s, now we have, it's really cool that you can actually stack these filters so that you can create more of a customized appearance of the tracking map based off of the information that you're wanting to visualize. Once we've reset that, now back to the original data set that we had, I also wanted to bring attention to being able to sort by category as well, which was a really cool feature. So if you wanted to look at all category 4s, now you can look at them just by themselves, which this was a really fun feature to put together, just because of the fact that there is just endless possibilities of ways that you could arrange this to make it more user friendly and get people intrigued, and increase their increase their enthusiasm towards this topic. Also wanted to bring attention is that you can also bring, with these TC dashboards, you can bring in search options to search your location, look at the legend, customize the layers, and also change the base maps. So getting into what I was talking about earlier with that subtle cold spot that I had mentioned in western Mississippi, what that brought attention to was there's actually relatively 2 prevailing steering patterns that actually bring TCs into the St. Louis area. With scenario 1, which I'll elaborate here, this is a really cool feature with being able to slide these geopotential height anomaly maps to show the difference in patterns. But scenario 1 here is depicted is interesting because it's kind of your classic Western Gulf hurricane that recurves northward and then northeastward as the West Coast trough encroaches and takes it out into the mid-latitudes. With this specific geopotential height anomaly map is static for the day of landfall, so you'll note that the storms do look like they're appearing to move into the ridge, but rest assured, so all the points that are down here are valid for that specific geopotential height anomaly map. So you'll note with scenario 1 is that there's a very strong anomalous ridge over the Ohio River Valley with a strong West Coast trough that eventually will then recurve these TCs out into the mid-latitudes and over St. Louis. Alternatively, with the scenario 2 map, it's a slightly different alteration to this type of pattern, where we see more TCs that are making landfall in the central and eastern Gulf, and even some in the southeastern United States, and with a more high latitude anomalous ridging over the Great Lakes and Canadian region. And with that being said, with a more retreated high latitude blocking pattern and not much of a West Coast trough to really recurve these very quickly, we get more of a system that kind of crawls northward, northwestward before slowly being taken out by the trough later on in the period. So this high latitude kind of blocking pattern basically keeps these storms more pinned up and can allow them to creep a little closer to St. Louis than you would originally have expected. So that being said too, I wanted to also visualize the geopotential height means and be able to provide a kind of an animation more or less of how these storms evolve with the pattern. And so with this, I'm basically exemplifying scenario 1 in this case. And obviously scenario 2 would be provided in the story map itself. But I just wanted to provide an example of how these geopotential height means are portraying the evolution of the storm motion as the high shifts out to the southeast of the storm, and you have more of a west coast trough that begins to kick the storm more to the northeast. With that being said too, these differences in patterns do end up having a drastic difference in impact to the St. Louis area that we've noted, which we'll get into here with the rainfall and tornado impacts. So the main thing with freshwater flooding, which is the predominant impact that a lot of these TCs bring well inland into our area especially, are a really important challenge to forecast, especially given the need for various different factors such as antecedent conditions, the forward speed of the tropical cyclone, as well as the timing of extratropical transition and interaction with the synoptic features that it's moving into. With that being said, that can basically provide a pretty wide range in terms of outcomes, as we'll see in the next couple slides. But basically, on average, the average TC brings about 1 to 3 inches of rainfall to the St. Louis area. However, I would say that there's a pretty drastic difference between outcomes from the high-end solutions to the low-end solutions as a result of just the differences in these other factors such as the extratropical transition. So moving forward, I wanted to help visualize how these storms move that amount of freshwater, amount of rainfall well inland. So this is visualized with the most impactful case that we looked at, which was Hurricane Ike and Gustav of 2008. With the figure here, or the map here is showing combined rainfall for Ike and Gustav, which shows a pretty clear swath of high rainfall of 8 to 10 inches across pretty much the majority of the Mississippi River Valley, all the way up into the Great Lakes, which definitely had a significant impact to our area, especially with Ike when it came to flash flooding and river flooding. That being said, too, this page wanted to look at the top five rainfall cases for both the states of Missouri and Illinois, given the fact that our CWA is basically right on the border of both states. And so, that being said, I wanted to be able to visualize each of these top 5 rainfall producers. So the map action function in the ArcGIS Online is a really cool feature to be able to click on these specific storms and be able to actually visualize the storm rainfall, as well as the track of the rainfall, or track of the storm, and the highest rainfall total that was recorded based off of WPC's TC rainfall page, which is maintained by David Roth. So being able to do that, I think it was a really cool way to visualize just exactly how these TCs evolve, especially when you look at the track of most of these TCs. As you'll see, as the extratropical transitions occurring, you'll see a much more higher rainfall actually rotate to the northwest quadrant of the cyclone, which in this case is important because of the fact that when we talk about the differences in steering patterns for these storms, we're seeing the storms that are recurving having higher rainfall over our area and upstream, which has drastic impacts obviously on our impacts for flooding. So that being said too, I wanted to also touch base on the tornado impacts as well. Even though we don't really see a ton of TC tornadoes, it does still have impact, even though, I mean, you can also argue, they're EF0, EF1, but regardless, they do actually have impacts to our area, and we have to obviously account for them in warnings and such and so forth. So I wanted to visualize the TC tornadoes that were produced by all of our storm cases, and then also look at specifically, how many of these are actually being produced in the states of Missouri and Illinois, which is highlighted in the differences in color, which Missouri and Illinois tornadoes are in pink. Basically, this is using the SBC tornado data set that they've compiled. And I basically went in and was able to identify all of the storm dates and storm locations, and basically take all of that data and subset it so that it could be created into its own TC tornado database for our specific storm cases for St. Louis. Looking at the tornado patterns, which is referring back to the steering patterns that we were talking about prior, there actually is a pretty notable difference in the amount of tornado production that occurs between the pattern 1 of the TCs that are recurving and pattern 2 of the storms that are moving more northwestward and slow with the high latitude blocking. And so if we take a look at that difference, we can see that this is in scenario 1, where we have all of these TCs recurving, and about 80% of the tornadoes that occurred in our St. Louis TC tornado cases occurred in scenario 1, which makes sense given the fact that if we account for the West Coast trough that is recurving these TCs, you're getting a lot more enhanced vertical shear, especially on the eastern side of these cyclones, which is going to obviously enhance miniature supercell development and thus tornadogenesis. By comparison, when we're looking at scenario 2, we see a pretty notable decrease in that total, which makes sense given the fact that, I mean, if we're not really seeing a whole lot of upward forcing, especially westerly shear on these TCs, you're really not going to get any kind of enhanced rotation that would be capable of producing a large amount of tropical cyclone tornadoes. And that's actually visualized. I was able to use the tropical package to create these plots where it's basically showing it's plotting the tornado paths basically in relation to the storm direction. So if we actually go back, we can actually see this is all of the cases basically. So you can see that majority of TC tornadoes, and it's worth noting that majority of TC tornadoes are occurring before they reach St. Louis, but they all are occurring pretty much in the northeast quadrant and in the northern semicircle. So that makes physical sense given the fact that vorticity or streamwise vorticity is going to be mostly enhanced in that part of the storm relative to upper level flow. So getting into this other dashboard that I created for the TC tornadoes so that you could also play with interactive map to look at all of the different TC tornadoes that were produced by the St. Louis TC cases. When we're looking at the histograms for tornadoes by EF or F rating, we can see that there's a notable discrepancy between scenario 1 and scenario 2, with scenario 1 producing a lot more TC tornadoes by comparison to scenario 2. And by looking at it by storm as well, it helps us kind of visualize which cases were really notorious for producing TC tornadoes in the leading up to St. Louis. Because again, I would make note that about 10% of all of the tornadoes that were produced by all these cases ended up occurring in Missouri or Illinois, so relatively a smaller number. Moving into the actual filtering function that I employed for this TC dashboard as well, it was quite interesting to be able to provide more of a filter by storm, so you could actually visualize these different storms and their tracks relative to the TC tornadoes that were produced. It's also really nice to be able to use these pop-ups to be more detailed with exactly where these tornadoes occurred, their length, their strength, the time and date, and all of that, that's important for individuals that, may be more curious about that. And then also moving into the sort by tornado rating itself, it can actually is pretty useful for identifying, exactly the placement of some of the strongest tornadoes and how those relate to maybe your area specifically. Given it's definitely, I think, a function that maybe not the most useful for maybe our area, given the fact that majority of them are EF1 or EF0, but still I think it was interesting to be able to visualize the differences in ratings relative to the TC tracks and everything. So that being said too, this TC climatology page itself was pretty broad stroked, I would say, in terms of discussing, the more intimate impacts that were to our area, specifically in terms of just the higher end cases. So to remedy some of that, we wanted to create a most significant storm story map that highlighted the more significant cases, which is basically its own story map, which I won't get into in too much detail. I'll allow you to kind of explore that yourself once it's public. But basically, I wanted to look at these 4 cases specifically, which was Hurricane Isaac in 2012 that moved inland after making landfall in southeast Louisiana, which was actually an interesting case because not because it was per se a flooding event, but more actually a drought buster to some degree in some areas, as well as a tornado producer for our area as well. We actually had a couple of TC tornadoes that occurred relatively close to the St. Louis area. So I felt like that was a case that could be definitely useful for individuals that were interested in knowing more about the life cycle of Hurricane Isaac and how it came to be. Same thing goes for Hurricane Gustav and Ike, which ended up being the most impactful duo of this entire TC climatology, as they were only 10 days apart from one another. So Gustav moving inland, it was already a pretty prolific rainfall producer for much of the area. And then you tack on another prolific rainfall producer in Hurricane Ike just 10 days later. And so it really set up for a significant flooding event for our area and much of the area in the Midwest and further south. So those 2 storms specifically were a really important component to wanting to create this story map. And then I also wanted to acknowledge some of the more historical storms that have occurred and actually have kind of some similarities to some of the more newer storms that we've seen in recent, which is Hurricane Carla in 1961, which made landfall in the south central Texas coast and then recurved towards St. Louis area, and was a prolific rainfall producer in its own right as well. It was one of the top rainfall producers of its time, and I want to make sure that it was acknowledged in this story map. That being said, I wanted to also kind of acknowledge all of the different data sources and things that went into creating such a TC climatology page. So the HRDAT2 was the primary data source for all of the TC data points and the tracks that were created as a result of those data points in the HRDAT2 CSV file. I wanted to make sure that was consistent throughout, so we made sure that it was something that was a consistent data source for the North Atlantic TCs. The SBC tornado data set from 1950 to 2020 was employed as well. That was primarily for the TC tornadoes, and basically wanted to just identify all of the TC tornadoes that occurred within this data set. It was a little grueling, I would say. I mean, I definitely had to, get in there with a fine-tooth comb and really, pull out as many of the cases that I could identify. And so that did take some time, but I definitely think it was well worth it. Other things that we were using were the WPC TC rainfall for the continental United States, which is all the rainfall gauges all the rainfall gauge data that was from 1900 to 2020. Again, it was maintained by David Roth. I believe he's actually working on the 2021 data now, but Fortunately for us, we won't have to update that given the fact that we didn't have any TC cases in 2021. Other things to take note of as well is we use the NOAA PSL monthly or daily composite page to create the composites for the geopotential height anomalies and means that ended up becoming the the main base maps for our steering maps, basically, for these storms. And then also to get more into detail with the most significant storms page, we also use the NHC tropical cyclone reports for those to make sure it's consistent. The data is consistent with each storm's life cycle, going into detail with each of those. The PRISM rainfall was actually employed for the Gustav, Ike, and Isaac cases because we wanted a little bit more of a finer resolution QPF map to make it a little bit more apparent of some of the more finer or more nuanced rainfall patterns that occurred with those storms, and that data was available only from 1980 to present, so we weren't able to do it for all of our top 5 rainfall cases, unfortunately. Hurricane Carla, I wanted to also acknowledge some of the storm summary from that storm was from WFO CRP's I believe 50th anniversary summary that they created, and as well as the 1954 to 1963 hurricane reanalysis, which actually ended up downgrading Hurricane Carla from a Category 5 to a Category 4. And then also just acknowledgement to UW-SIMS and NCEI for their data for satellite and radar. Basically, to recap for the methodology, I created all of these shapefiles and raster layers in ArcGIS Pro, and then we're basically exporting them to ArcGIS Online and managing from there all of the different pop-ups and all of the different data that was visualized in each of these web maps and put in the story map. The TC cases that were identified were using the NOAA Office of Coastal Management and the historical hurricane tracks page that they have. And basically, we just took that and looked at the 300-mile radius and then basically compiled all of the different cases that it gave us. Additional cases, I will say, were considered and removed based off of the prior list that we had, prior TC cases that we had listed from the WFO prior. That being said, I would say like the classic cases that were omitted from this TC climatology were storms like Audrey and Erin, which were prolific rainfall producers, but were not considered fully tropical or even post-tropical at that time, given the fact that they had moved well inland and already fully transitioned at that point. Further, like in Audrey's case, it was a frontal interaction that was primarily the facilitator of the heavy rainfall that occurred in that event. When it came to the TC dashboard and TC tornado dashboards that I had illustrated using the filters, I was able to create those by creating new attributes for month, decade, and peak intensity, as well as storm by storm rating and state to be able to create those. So those kind of attributes, I would say, are crucial if you're wanting to recreate something like that, and creating a filter is that those data sets do not by default have those attributes, but if you're willing to take the time to sit down and create those attributes, it definitely, I think, was well worth it to be able to create these filters and organize the data more efficiently. Again, like I said, the steering patterns were created using the NOAA PSL composites by georeferencing them in ArcGIS Pro, and then also having to go in and do a little bit of dirty work, doing some tracing of the isohypses of the geopotential heights in order to create those maps. But I definitely say I'm very proud of how those maps ended up coming out. So all that being said, I think it was well worth it. And then for the WPC TC rainfall rain gauge data, I used the inverse distance weighting interpolation to create those more smoothed maps that we were referencing earlier in the rainfall impact section. Basically just to provide more spatial consistency throughout the whole data set, given the fact that we only have PRISM data from 1980 to current day. So just wanting to have a more consistent rainfall QPF map. So that being said, I would say if you want a little bit more detail about the methodology that I put forth, I do list that in the end of the story map itself. If you're more interested in getting into the nitty gritty of some of the stuff that I did to create these maps in the story map, definitely feel free to read that. And also, if you have any other further questions, obviously you can email me or ask me after the end of this presentation. With that being said, I wanted to provide a special thank you to Matt Beitcher, Jim King, and Fred Glass for their contributions in this project. I really could not have done it without their guidance and support during this whole process. And I also wanted to give a shout out to the rest of the WFO St. Louis staff, because I really have enjoyed my time, and I really appreciate their hospitality and guidance that they provided while I was in the office and even during telework and everything. I think that it's just been a great experience overall, and I could not have done anything without them. And it's definitely, I'm gonna cherish this time definitely for the rest of my career. So thank you so much for your time. That is actually the end of my presentation. So with that, I'll take any questions that you might have.